Welcome everybody. I'm very glad to see so many faces today and so many people having interest in our topic. My name is Irina Smanova, and in my function of the Vice President of this university, I welcome all of you who are present here in Audimax 2 and also are present online. And I would like to especially welcome also the members of our University Board, our President Andreas Zimgil and Vice President for Teaching Thorsten Kern. And I also welcome our participants online. We have around 100 people who are following us online today. So we are very happy about this interest. So where we are today, we are in the future lecture. And today's future lecture has a future in its title. It's the future of maritime system. And the purpose of the future lecture is not only that we learn something new and learn something from each other, but also from our guest speakers, but also that we afterwards discuss what we have learned and discuss maybe our different ideas and maybe also controversial part of that. And especially for that, I'm very happy that there are so many experts here today. And we have also the experts from various countries abroad. And I would like to especially welcome the Technical Committee of the International Think Tank Conference here. Here we have the chair of this committee, Professor Tian Yukui, and we have also Dr. Ansein, Mr. Hesete, and Mr. Böhm, who are all belonging to this International Tank Conference main committee, and this is a global recognized organization, and the conference takes place as a key role in advancing maritime research and engineering internationally. So I suggest we give a special warm welcome from our guests from abroad. Thank you very much for being with us today. And so that we can discuss with our international guests and also with each other, especially by these unusual warm temperatures, we will have something to drink and something to eat afterwards. So it's, I would say this is a good time to stay here and to think about the nice time afterwards. For the discussion, we have a very nice poster session outside. So please take a time to appreciate also the posters which were prepared by our university members and also by our students. So I would like today to, after the welcoming our special guest, also to present today's speaker. And we have today two lectures. And the first lecturer is Mrs. Silke Lehmköster, who is here with us. She's the Managing Director Fleet at Hapag-Lloyd, also Flottenchefen. And in her role, she oversees fleet management, fleet innovation and technology, fleet analytics, and charter fleet management. And I would like to say that her maritime career began already in 2005 as a deck cadet. And she was leading after that to the roles of the nautical watch officer, chief officer and master, becoming one of the Hapag-Lloyd's first female captains. And this is very nice that we also have this role. In 2020, she moved ashore and to take the senior leadership position in marine human resource and fleet management, where she has led innovating shipping vessels project and technical transformations. And today she is also the part of the group which has a leading efforts toward decarbonization of the fleet as a part of Hapag-Lloyd's climate neutral goals for 2045. So we will listen to it today and hope that this goal will be achieved 2045. And as a second speaker, we have today Dr. Florian Kluwe, who is graduated in naval architecture from our university, Hamburg University of Technology, in 2004. And he also got his PhD from our colleague, Professor Krüger. So he's yes. And the doctoral research was on the dynamic stability of ships in heavy seas. and it was also recognized with the Georg Weinblum Prize. And Dr. Kluwe has held several leadership positions in maritime industry, including Flensburger Schiffbaugesellschaft GmbH and Hamburgische Schiffbauversuchsanstalt. And since July 2023, he has been managing director of the Ship Design and Consult GmbH. And alongside with his industrial career, he has also lectured at Kiel University's applied side, so our colleague here, and has been actively involved in the Georg Weinblum Foundation and Schiffbau Technische Gesellschaft. He has also served as a member of the executive board and vice chairman there since 2014. And Dr. Kluwe will speak today about the decarbonization of maritime transport by wind. So we are very much looking forward to these both very nice lectures. And with that, I'm looking forward for the first lecture of Silke Lehmköster, where we will learn about the future of the maritime transport and decarbonization. Please welcome Mrs. Lehmköster.
Warm welcome. And I thought I will start first, who's actually Hapag-Lloyd? And just to give you a short glimpse, we have been here for more than 175 years. So we have seen quite some changes, and I think we are also quite good in always reinventing ourselves, because otherwise we would not be here anymore. Our headquarters is here in Hamburg, and I will come to that a little bit later on again, why Hamburg is so important for us and why you are also so important. We started to look also into terminal investments, as I think it's quite obvious. If you have investments in the terminal, you are also able to call the port when you want to do it and not when others are telling you to do so. And we call more than 600 ports, so we are a global player. We call those 600 ports with around about 300 vessels, and as you can imagine, there's always something to do, whether it is with the crew, whether it is in terms of innovation, or also in renewing the fleet. On those vessels, we transport around about 12.5 million containers. We strive to do this, to upgrade this. And ashore, we are more than 18,000 people globally. But I have a very strong and dedicated team here in Hamburg. We are in fleet altogether about 100 persons, and looking at everything what can be done around a vessel. Today I would like to say a few words about what is in the future, what is the outlook, and why is shipbuilding in Germany still so very important. And I can say so because I was searching for my head of fleet innovation and new building. Very happy that Fritjof Rode is here today as well. And I realized there are not so many persons with a shipbuilding background here in Germany anymore. And frankly speaking, I need them, because when we look what is our goal going forward to 2045 and in the first step until 2030, I need innovation. I need persons who are looking forward, that they don't take a ship granted because it was built like this 10 years ago. It still fits into our path forward. What means the path forward? Until 2045, we want to reduce our emissions by 1/3. And we defined 4 levers, basically 5, on how to do so. The first one is pretty easy. We want to grow the fleet, as normally bigger vessels are more efficient, and we also need to renew ships. Normally, we say a container vessel stays in our fleet for 25 years. Due to all the global or geopolitical circumstances, we are expanding those 25 years at the moment, but normally a container vessel after 25 years is actually due for recycling. When we are looking into this renewal, the question is always what is out there on the market. Do we see any changes in the hull shape, in the propulsion? How do we need to design a vessel nowadays? Or what do we need to bring up with the design houses that we work together with in China? The other part is, of course, the slow steaming. That sounds now pretty easy. You just sail slower with the vessel, less emissions, less bunker consumption, everything is fine. But if your vessel, and I guess you know it better than me, is actually designed for 25 knots, and suddenly you sail the vessel with 15 knots, it does not necessarily mean that you have the most efficient vessel. And this is then again where fleet innovation comes into the game and says, okay, we might need to do something on that vessel to make it efficient then also at 15 knots. This is where fleet upgrade plays a huge role, and we have a lot of projects going on, but also we had quite some projects in the past few years that were going on. And then there's, of course, the topic of alternative fuels. We said we want to be fuel agnostic. We cannot say that one fuel will save us in the future. We don't know where we will be in 2045. Could be everything. But on the way, we cannot stop ordering vessels. We cannot stop rebuilding or upgrading vessels. We need to stay, like I said, fuel agnostic. We look at different fuels, and we also gain experience. And that was quite interesting when we brought our LNG vessels, for example, into the fleet. Everyone thought, with a non-engineering background, it's like just a different car. It's like an electric car. You go in, you start driving. Fun fact, it's not. We learned a lot in the past 2 years. I guess we will also learn a lot on the way going forward. And then we said, on the way to 2030, 2045, what do we know now today? In 2026, we put together the strategy in 2022. What do we know? What is up on the market in 10 years and 15 years? So there might be a solution that at the moment looks so strange and absolutely not doable. And in 10 years we say, it was pretty obvious, we should have done this a lot earlier. Maybe it's the wind propulsion. So what have we been doing? We call it fleet upgrades. We love abbreviations in Hapag-Lloyd, so it was FUP, Fleet Upgrade Program. And we had a wave 1, as we like to call it, and that took place basically between 2022 and 25. And this is where shipbuilding, where innovation comes into the play. Like I said, we built vessels, and I sailed on vessels that were designed for 25 knots. There's a good reason why we normally have in our ship name a city name and express. We were the fastest one, and me as a nautical officer, I loved it. It solved a lot of problems. If I tell this to my CEO, he would look at me and say, no, sorry, way too much bunker consumption. Every drop counts. And when we look at the bulbous bow designed for 25 knots, it looks completely different than one that is designed for 15 knots. So we started to exchange one bulbous bow after the next one. Same goes for the propeller. Same game, the one for 25 knots looks completely different than designed for 15 knots. But that was not the only thing that we looked into. We also looked into full blast and premium painting the hull, as we also found out we can do everything around the vessel, but if the paint is not properly done, it's all the upgrades are good for nothing. And also here we have seen this when we had our vessels in the Persian Gulf, sitting there for 4 weeks, 5 weeks, 6 weeks. I tend to say that we have now on some vessels the Great Barrier Reef underneath, and it has a huge impact on how fast we were able to sail out of the Strait of Hormuz. A vessel that was able to sail before 18, 19 knots, so a decent speed for nowadays, suddenly sailed with 11 knots. And like, okay, we can exchange the bulbous bow, we can exchange the propeller, we can do whatever. But if we leave behind the paint or the hull, the whole hull, we are losing out big time. So looking into paint is also a huge topic, something that we did not look so much into a few years back. Something that is not necessarily connected to at the first spot to bunker consumption is also what we call loadability push. That means we carry more containers on the same vessel than before. We can do this by extending the lushing bridges, so-called Mickey Mouses on the side. But we went also that far that we really cut the wheelhouse, inserted 2 decks, put back the top of the wheelhouse, and by that we can carry up to 1,000 containers more. That is, by the end of the day, also less bunker consumption because you can carry more containers on the same vessel. And also, of course, we did not need to order vessels when we were absolutely not sure which kind of propulsion we would like to invest into. But all of this happens at Ballindam, happens in the team of Fritjof, looking at vessels. When are they going into dry docking? When do we need to check on the design how the new bulbous bow should look like? When do we need to order the propeller? How do we get the propeller, necessarily from Germany, to China into the dry dock? So all of this coordination, and of course also all the understanding of what is the best to do with the vessel. And we had quite some projects going on. We retrofitted about 100 propellers, about 50 bulbous bows. As you can see, paint was really quite a hot topic. And we managed to increase the efficiency of the vessels to up to 14%. And this really was the team here in Hamburg, coordinating everything with in-house, other departments, so that actually the vessel is at the right time, at the right spot. But we have a network. As I said, we have about 13 million containers that we want to transport. So this is how we make the money, and also how we make the money to invest into those projects. That means this is really a very tight planning, and everything needs to fit together. Also with the loadability push, we had speed lanes where we simply managed to recalculate a little bit with the loading program, but then really up to bridge elevation where the vessel was out of service for 45 days. This is when normally network says 1.5 months, we need a charter vessel to go in. That means it's quite expensive. But on the other hand, after 45 days, we redelivered a vessel with 1,000 container spots more. That was the moment when network started to smile again. But what I want to say is, of course, shipbuilding, and for a short moment I was also thinking about whether I would like to go into this direction than actually being a sailor. I think was completely different when I looked at what I want to become 20 or 25 years ago. And I remember quite well that I was told, yeah, but in Germany there are no shipyards anymore. And yes, one could argue this is partially true, but that does not mean that shipbuilding is not something essential we need. We need to, in the forward, really take care of how shall vessels look like. We see now also with all the geopolitical hurdles, bunker consumption is key. And of course, it's a question, why would we invest into all of this? It costs us a lot of money. Yes, because the payback, the return of investment is still good. A vessel is an investment for 25 years, and whether it's a car that you upgrade, whether it's your home that you upgrade, same goes with a vessel. And for that, we need the engineering here. We need someone who's connecting from here in Hamburg to China or everywhere else where we look into when we go into dry dock. And when I say we have the fleet upgrades, wave 1, we obviously also have a wave 2. And now it becomes a little bit more nitty-gritty detail, where it is easy and obvious with the bulbous bow and propeller, and also the paint is of course a question now, what can we do on a vessel that is already optimized? Is this done, or is there something out on the market that we need to check upon? And we did so, of course, very publicly, and if you sit at the Elbstrand, you see now vessels with a windshield. Probably debatable if this looks very pretty, but still it does make sense. It's of course not the biggest saving as we see with a new propeller, but still it does make sense. The same goes for machinery and equipment upgrade. when I have to sell this in-house, I always say it's a little bit like car tuning. Is really the whole combustion process perfect? Where can we do other auto tuning? Sounds a little bit like back in the teenager years when you would upgrade your mofa. What is the best that you can still tune out of your mofa? And now it's about what can you do best on the vessel. We have now electronic engines. I used to sail also on the MC engines from MAN, so really the very old ones that you could also manually check on everything what you would like to do. Nowadays, if you go on board of a vessel, so many things are electronically mastered. And of course, there are possibilities, there are chances to make them better than they are at the moment. And this is exactly where we need to check our fleet against. We, of course, also look into shaft generators because, unfortunately, not all of our vessels have one. We are always fighting that this comes in at the package of the new building. But we still look if we can retrofit one. Then we also look at simple things like we transport reefer containers, so cooling containers in the cargo hold. Can we do something with automation? Because out of experience, I know that the chief mate normally switches on the starboard side ventilation on Monday, and on Tuesday switches to starboard side, and then again on port side, and so on. Is that really efficient? I doubt it, despite the fact I did it like this as well. We also look at the batteries. We have seen the first coaster vessels where they installed a lot of batteries and are able to sail, at least in peak times, or cover the peak times. We drive with electric cars, so why shouldn't this be possible on a vessel as well? Maybe not on the 24,000 TEU vessels going trans or around the Cape of Good Hope, but are there vessels in our fleet where we could do that? We at least need to ask ourselves those kind of questions. And this is now a lot about scanning the market, talking to each other, and also, of course, thinking, hey, what can we do? Be open-minded and staying curious. Of course, if your vessel already looks perfect, and then question, is it perfect? So this is our wave 2. And next to it, and here again, we need people who understand how a vessel looks like, how it shall be designed, is our future fleet. What is it in for our new buildings? We got the last 24,000 TEU vessels last year. We are very proud on our Hamburg class. We learned a lot on LNG. Like I said, it's not you go on board and you start the engine and say, hey, everything is just like copy-paste from our complete fleet. But we learned, and this made us confident to order another 24 new buildings, smaller ones, as we also need to invest into the whole portfolio of our fleet. And then, of course, methanol comes into the game. And this is where I say we need to stay fuel agnostic. We ordered methanol vessels, but we also are currently converting standard vessel standard vessels into methanol. We have been a little bit hesitant because we also converted one standard vessel into LNG, and that was during COVID, and we learned a lot about the boundaries, what can be done or not be done. But the first retrofit is now happily sailing. Also here we learn, and by now retrofitting 5 vessels together with Seaspan, we have the opportunity to learn how does a methanol engine work. What is good, what is not so good, where can we tune on the engine, what do we also see in terms of the engine. And when our dual fuel methanol vessels will come, will be delivered from the yard, we hope that we are already fully into the picture so that we can look at ammonia. That's the next thing. It's on the lineup. We, from time to time, also look into what is possible with nuclear. So this is the call, what I say, to stay curious, not to write off something, we have seen it, doesn't work, we put it forever away. We have also looked into wind propulsion. For various reasons, we said, not today, maybe in a year, but it's an evergreen. It's once a year we do a review. Where do we stand nowadays with wind propulsion? Where do we stand nowadays in terms of nuclear? how far did ammonia actually establish itself in the market? We need to work on everything what is possible. And what we also learned, we need to invest into fuels as well. And this is where we come again to the methanol vessels. We actually partnered up with a fuel plant or a green methanol plant to make sure that we also get the fuels that we want. Because by the end of the day, it's wonderful if we all believe in LNG and methanol and ammonia and whatnot. If we don't get the fuel, we will not be able to fulfill actually our strategy. And this is again where we as a team in Hapag-Lloyd need to work on always the availability as well, saying our vessel is now ready, the fuel is ready, okay, the crew is ready. We shall never forget the crew who needs to be upskilled as well. And then we sail and we learn, and by that, step by step, we come closer to our strategy 2030. And by the end, of course, also to 2045, which is, of course, an ambitious target and something where we are lately been asked quite a lot, why do you still pursue that way? Why don't you call it off? There are no hard boundaries anymore. People start discussing whether we need to still fulfill it, despite the fact that an IMO net zero framework is on the horizon and whatnot. And we say, if we save fuel, we save money. That is the perspective of a company. But at the same time, we as a company have an obligation to fulfill the decarbonization. It's the contract with the next generation that we take care. And we are all, as we sit here together, in the seat of changing something. And I think we also give a great opportunity to change something going forward for the next generation and actually decarb a fleet, which I think is super, super exciting. I sailed on board of a vessel where we used 350 tons of fuel oil every day. And I'm very happy that we are not there anymore, but rather invest into our new building program, where we need engineers. I can only repeat myself, shipbuilding is important here in Germany as well, despite sometimes the view is different. We think it is. Thank you.
And we welcome Dr. Kluwe on stage, who will explain us more about the decarbonization. We have already heard this is something for future. So we are looking forward to that. Please.
Thank you very much for the warm welcome. And I'm happy to see so many people here interested in this topic. Well, last weekend, we had, for the first time, temperatures above 40 degrees in Germany in June. So climate change is real. And shipping contributes to that global warming with around 900 million tons of CO2 equivalent every year. That's 3% of the total emissions we have worldwide. So we need to get rid of that, and IMO has adopted a greenhouse gas strategy aiming at a 20 to 30% reduction until 2030, and the target is to be net zero in 2050. So I won't talk much about the measures because Ms. Lehmköster has already very nicely shown us what is available today, what we can do to ships in retrofit, but as well in the same categories it applies also to the new buildings. Slow steaming, tackling improvements. So that roughly allows us to reduce the carbon intensity of vessels by around, I would say, 50%. So the rest needs to come from carbon neutral alternative fuels. And apart from the price, which is not, at the end, if everybody has to pay it, not a real problem, we have a challenge with the availability. If you look on the right-hand side to the statistics, the prediction of availability taken from DNV, you can see that we, as the shipping sector, would take a major part, even the most optimistic prognosis of ramping up the availability, we would take a lot of the available fuel, which will not be the reality because other sectors also need to decarbonize. So we need to find something else. And Oh, unfortunately, this is already shown. Is that the PDF version, or is that the? Could you do the PPTX as well? Because there's some animation in it, so unfortunately that would otherwise I won't be able to show everything. Because I wanted to show there's a very nice sailing ship behind that.
You want to see that?
Of course, yeah. Because what mankind has done for centuries is using the power of wind. So rushing through that. That's the nice sailing vessel. So that's how we transported our goods over the oceans for centuries. So, and well, that's not, so wind propulsion is not really innovative. We did it for centuries, and it's a proven technology anyhow. So the potential is there, and it makes sense to use it because wind is for free. Can we just go back and just continue or go back to building those sailing vessels? Obviously not, for various reasons, but the most striking one is probably the one I've shown here, comparing the transport volumes from the ancient times where we had the sailing vessels to nowadays. That's roughly the factor 2,400. So no way that we could transport these goods with these old technology, old-fashioned sailing vessels. So what's the consequence? It's still attractive to use this wind power, but we need to rethink ship design. We need to reinvent sailing vessels. So that comes with various aspects. For example, I need to look in the sail system itself, those devices that catch the wind and make some propulsive force out of it. I need to integrate them on board somehow. I need to find appropriate space. I need to talk about hull performance. By hull performance, I mean that these sail systems completely change the forces that are acting on the vessel. So, and I need to account on the hull for that. I need to talk and think about routes. Wind is a natural resource which is not equally distributed over the globe, neither from the direction nor from the speed. So my ship design also needs to be adapted on specific transport tasks and transport routes. And finally, a very important topic, I need to talk about safety. If you look back to those old ships, it was quite common that they were severely damaged in heavy weather. It was accepted that many seafarers did not return safe home. So no way we would accept such kind of safety level nowadays in shipping. Let's start right away with the sail system itself. The last years have seen a lot of new companies, startups, providing new systems, ideas to the market. And I tried to, it's worthwhile to categorize this a bit and to show which technologies fundamentally are available to catch the wind. So this is something I have not done myself, but this is something that made Peter Schenzle, the well-known expert, who spent almost his entire professional life in research and development of sailing cargo vessels. And I'm very proud and happy that he's in the audience today. Welcome, Mr. Schenzle, that you're listening today. So fundamentally, there are two blocks. One thing is the classical airfoil. There are basically two different approaches. One is the square rig and the other one the fore and aft rig, which differ mainly how they are aligned relative to the vessel. And then I can have different implementations, either with soft sails, or sail canvas, which has no own form stability, throughout to the rigid wing sails, which is comparable to the wing of an airplane. So I have a prescribed profile form made from GFRP, aluminium, whatever. So that's the classical approaches. And then I have somewhat more unconventional systems like the nowadays very popular rotor sails, making use of the Magnus effect. I can have sails that generate the lift by manipulating the boundary layer, sucking in air, accelerating the flow, generating lift. We have the kite systems, which have the advantage that they can operate at very high altitudes, making use of the higher wind speeds there. And finally, a bit an exotic one. I, of course, could theoretically also fit wind turbines on board of vessels, generating energy. And the fun fact is that this is the only system that theoretically could sail directly into the wind. Although at a very, very low efficiency, and efficiency is a very good keyword. If you look, where are we at the moment from the technology point of view? If you look at the light blue line, that's a classical square rig from such kind of ships I've shown on the previous slide. And on the top, you can see modern wing sails, rotor sails, and that is roughly about the factor of 5 of power density. So that's where we are at the moment, and I'm pretty sure that research will push the boundary a bit further. So the potential is huge there. But I, of course, need to accommodate these systems on board somehow. And the most important aspect is usability. I want to transport something, so I must not disturb these cargo operations. And if you look at the right-hand side, there's a typical coastal vessel. Here already in a version, what we call WASP, wind-assisted propulsion, with 2 relatively small sail systems at the front. These vessels, for example, have a very long single cargo hold amidships, and they also used to transport cargo deck loads. And furthermore, you can see in yellow this gantry crane, which is there for handling the pontoon hedge covers. So all this area is in principle lost to accommodate sails on such kind of designs. So I'm quite restricted here. And this is really a very important and sometimes also difficult task in ship design to appropriately place these systems on board. Second point here on the slide is foundations. That is not so complicated on this vessel, but I somehow need to transfer these forces, these propulsive forces I have, into the vessel structure. And there are, for example, other vessel types like passenger vessels where this is not so easy indeed. And then we have the topic of interaction. So looking at the sketch below, you can see that there is a deck house, and there's a sail behind. You might want to have that configuration, but you easily can see that you will have a severe influence of the deck house regarding the inflow to the sail here. So that's an important interaction, and that can influence efficiency quite significantly. If we are serious with wind propulsion, then we of course do not have only one sail, but we have a whole array of sails. And then we get an interaction between the sail systems, and placing this array of sails relative to the superstructures, to the hull, is a real important task, taking into account all the boundary conditions. But you can heavily influence the practical performance you can get out of it. Usually you would do that by extensive CFD simulations nowadays in optimization. But just to give a rough idea, I again make use of the vast material of Peter Schenzle, who has proposed a very simple approach in momentum theory, which shows in principle the importance of that task, showing here the total length of the sail array of S and the sail height H. And if you look at the diagram, you can see if I take it's roughly, I can't see any pointer, there's a pointer, but not on the right. Yeah, you can see that we roughly have a relation of 2 here, and if you take 4 sail systems, that you can see that effectively we're ending up roughly around 3 sail systems. That means if I would place the sail array in that dense as I have it here, I would probably end, that's okay, thank you. I would probably end up losing the efficiency or the effectiveness of one complete sail system. So that just to give you an idea how important this is, to integrate that in a proper way. So next one, this is in principle that's my favorite topic, because you can see a lot of stupid things being implemented currently on board. Taking the ship, it's inherently that sail systems that generate thrust also generate a cross force. And how do we compensate for that cross force? Well, that needs to come from the hydrodynamic underwater hull. And how does this happen? I get a drift angle. And then if I look at the cross forces, the cross force distribution of an underwater hull, I get something like that. So probably my center of effort will be somewhere there in the front, where you can see the red dot. And the center of effort of my sails is somewhere there. So what is the result? I get a not so small yaw moment, which tries to turn the vessel into the wind. How do I compensate for that? Okay, I have a control surface that's called rudder, and I have a rudder angle, and then if I'm lucky, I can control the vessel. But that comes at a cost. Again, I will have added resistance threatening the efficiency. So balancing this system is a very important task. Either shifting sails forward, or I can try to shift the center of effort of the hydrodynamic forces backward, which on classical vessels you often see this rake of keel, for example, which is probably not a good idea because no one wants to dock your vessel and you might get into draft restrictions. But at the end, this is something that really is a driver for ship design when doing sailing vessels. And then finally, we have the topic of routes. Let's assume we have a transport route here from Europe to South America. From that, I can take long-term statistics, wind distribution in terms of wind direction and wind speed. At the same time, I can get for the sail system or the combination of sail systems or the entire array, including the hydrodynamic forces, a performance diagram is shown here, showing depending on the forwards, depending on the speed, depending on the angle of apparent wind, a performance driving thrust force. And from that, I can get a long-term statistics on the system's efficiency, here expressed in terms of power reduction I can get, or the substitution rate, how we call it. You can see in that specific example, I've put a suction wing and a rotor sail here in that example. In that case, for that specific setup, the rotor sail would be clearly superior. But if I change the route, it could be completely vice versa. So the design decision is very much driven by the trade pattern of the vessel, much more than we have it for ships nowadays. And that needs to be accounted in ship design as well. And just to give you again some order of magnitude, for those vessels sailing with one or two sail systems, the classical, what we call wind-assisted propulsion vessels, there we see average reduction rates of 5 to 10%. And if you go for the vessels, what we call primary wind propulsion vessels, they end up at 50 to 60% substitution rate of conventional propulsion to wind propulsion. So why is this figure not more? This figure could be higher if we would no longer stick to just-in-time delivery. So if you would relax crossing times and accept the vessels, if conditions are not favorable on a route, have longer crossing times, then I probably would have higher figures here, 80, 90%, whatever. So, remembering the circle I put at the beginning, there's the final topic of safety, and safety is now a topic where we could have at least one more lecture on, because there are so many aspects to tackle. But I've picked out one thing because that is something where we're currently in a situation where we still have a certain barrier for the introduction of wind propulsion. That's the stability. At the moment, at IMO, if you look at the code on intake stability, for example, of IMO, you won't even find the word sail somewhere. So there are the expert already there. So what we have there is that we have no dedicated criterion for sailing. We have the IMO weather criterion, but for the IMO weather criterion, for example, we would need to investigate something like that shown here. So that means I would need to assume my vessel with the sails completely pulled tight, a beam to the wind, and then taking the worst case scenario. a situation that in practice will never happen because no one will operate the vessel in this case, in that situation. And secondly, the vessel even would not be willing to float in that condition because I've shown that most likely the vessel in an emergency and I can't handle the ship anymore will turn most likely into the wind. So therefore, I still stuck to that. I have that in the stability booklet, resulting in the requirement that I need to reef rather early, although at certain wind speeds I would still be able to operate the vessel safely and could make a lot of, could gain a lot of wind force out of the sails. But I'm not allowed, I need to reef because theoretically at that stability value I have, I'm not allowed to operate the vessel. So here we need to really gain experience, improve knowledge, do proper risk analysis and find out what is a proper approach, utilizing also the modern technologies we have at hand, like onboard operator guidance, guidance to the crew, automation systems to really exploit the full potential. So finally, key takeaways. Substitution rate is substantial and so there's a lot of gain we can expect from the sail systems. Technology, the sail systems are evolving. We are in an early stage of implementation. There is a lot of, as I said, startups, new approaches that needs to gain maturity, needs to transform into products, and we need to work on further improving the technology, for which we need, obviously, engineers. Ship designs become more diverse. We need new approaches. We will see new ship types probably, and we have ship types where it's probably more an easy task to implement wind propulsion. Others, unfortunately, your fleet is a bit more complicated, Ms. Lehmköster. This is probably not the low-hanging fruit to put wind propulsion on the container vessels. But we need to think about new approaches. There's always a solution. I agree with you. I also want to stress that it's becoming more important to do these tailor-made route-specific designs. That is, in my eyes, really, really important to exploit the potential of wind propulsion. And again, this requires proper engineering, and we need proper tools and proper simulations methods for that. Regulatory framework is, in my eyes, incomplete, not only related to stability, but in many aspects. I'm also currently starting to think there are correspondence groups working on that. They are now collecting knowledge, but there is a real lack. There's a gap of research and development on exactly these topics and how to deal with that. Also for that, we need research and development, and that again requires engineers in our segment. So I have not talked about costs intentionally because that's something for the finance guys. But I can tell you that the business case is not a stable one. So costs are very high. Not only because we are at the moment lacking a bit the incentives on the regulatory side, but also on the technical side. These sail systems I can buy nowadays, that's more or less handcrafted prototypes coming at associated costs. So again, the engineers need to do their homework and we need to scale up industrial production. We need to do proper production engineering to automate the manufacturing. That's big components, GFRP components, even bigger than those we know from building planes. Also a task for engineers to make all these nice designs become reality. Thank you very much.